Hello, my name is Jyot Joshi and I am studying at Marwadi University. I am currently pursuing my BTech degree in ICT, Information and Communication Technology. Today, I am going to talk about frequency division multiplexing, a conceptualization topic given and guided by Professor Chandrasi Parmar under the subject of ICE, Introduction to Communication Engineering. So let's start. So, what is frequency division multiplexing? Frequency division multiplexing is an analog technique that can be applied when the bandwidth of the link is greater than the combined bandwidth of the signal to be transmitted. In FOM, the signals generated by each sending device modulate different carrier frequencies. These modulated signals are then combined into a single composite signal that can be transmitted by the link. Carrier frequencies are separated by sufficient bandwidth to accommodate the modulated signal. These bandwidth ranges are the channels through which the various signal travels. Channels can be separated by strips of unused bandwidth guards bands to prevent the single signals from overlapping. In addition, carrier frequencies must not interfere with the original data frequency. We consider FDM to be an analog multiplexing technique. However, this does not mean that FDM cannot be used to combine sources sending digital signals. So, a digital signal can be converted to an analog signal before FDM is used to multiplex them. So, here is the modulation process. Each source generates a signal of a similar frequency range. Inside the multiplexer, these similar signals modulates different carrier frequencies. The resulting modulated signals are then combined into a single composite signal that is sent out over a media link that has enough bandwidth to accommodate it. As you can clearly see in the figure, that the resulting modulated signal are then combined into a single composite signal that is sent out over a media link that has enough bandwidth to accommodate it. Now let's take a look at the demodulation process. So in demodulation process, it uses a series of filters to decompose the modulated signal into its constituent component signals. The individual signals are then passed to demodulator that separates them from their carriers and passes them to output lines. This figure shows the demodulation of FDM signal. Now, analog hierarchy. To maximize the efficiency of their infrastructure, telephone companies have traditionally multiplexed signals from lower bandwidth lines onto higher bandwidth lines, in which way many switched or leased lines can be combined into fewer but bigger channels. For analog lines, FDM is used. One of these hierarchical systems used at AT&T is made up of groups, supergroups, master groups, and jumbo groups. In this analog hierarchy, 12 voice channels are multiplexed onto a higher bandwidth line to create a group. So then a group has 48 kHz of bandwidth and supports 12 voice channels. At the next level, up to 5 groups can be multiplexed to create a composite signal called a supergroup. So a supergroup has a bandwidth of 240 kHz and supports up to 60 voice channels. Then supergroups can be made up of either 5 groups or 60 independent voice channels. At the next level, 10 supergroups are multiplexed to create a master group. A master group must have 2.40 MHz of bandwidth, but the need for guard bands between the supergroups increases the necessary bandwidth to 2.52 MHz. Master groups support up to 600 voice channels. Finally, 6 master groups can be combined into a jumbo group. A jumbo group that must have 15.12 MHz but is augmented to 16.984 MHz to allow for the guard bands between the master groups. Here are the some applications of FDM. So, as you can see, FDM can also be used to combine signals before final modulation onto a carrier wave. In this case, the carrier signals are referred to as subcarriers. An example is stereo FM transmission, where a 38 kHz subcarrier is used to separate the left-right difference signal from the central left-right sum channel prior to the frequency modulation of the composite signal. An analog and NTSC television channel is divided into subcarrier frequencies for video, color, and audio. DSL uses different frequencies for voice and for upstream and downstream data transmission on the same conductors, which is also an example of frequency duplex. Anyone wonders how many signals of FM transmission can transmit, and we can choose on what frequency we need to hear the FM. So this uses FDM, as many signals are transmitted over the same line but the different frequencies. So this is a modern example of FDM application. Then the first generation of cellular telephones also uses FDM. Yes, the first generation of cellular telephones. Each user is assigned two 30 kilohertz channels, one for sending voice and other for receiving. The voice signal, which has bandwidth of 3 kilohertz, is modulated by using FM. Remember that an FM signal has a bandwidth 10 times of the modulating signal, which means each channel has 30 kilohertz of bandwidth. Therefore, each user is given by the base station a 60 kilohertz bandwidth in a range available at the time of the call. Now, it is a type of FDM. In telecommunication, orthogonal frequency division multiplexing is a type of digital transmission and a method of encoding digital data on multiple carrier frequencies. OFDM has developed into a popular scheme for wideband digital communication used in applications such as digital television and audio broadcasting, DSL internet access, wireless networks, power line networks, and 4G and 5G mobile communication. Here is the another one, non-orthogonal frequency division multiplexing. It is a method of encoding digital data on multiple carrier frequencies with non-orthogonal intervals between frequency of subcarriers. And OFDM signals can be used in communication and radar system. So these were the two types of FDM basically used, and this was the part of FDM. And thank you. If you have any doubt, you can feel free to ask in comment section. Thank you so much.